एजुकेशनल और टेक्नोलॉजी रिलेटेड वीडियोस के लिए सब्सक्राइब कीजिए और बेल आइकॉन को दबाइए।
Hello friends, my name is Sadashiv Thackeray and you are watching Knowledge Planet. Today we are going to discuss about acids, bases and salt. This is the first part of video in which you will learn what is acid and bases. So let's start. Friends, the taste of food is a sour or bitter is depend upon the acid or base which are present in that food. If someone in your family is suffering from the problem of acidity due to the overeating, which of the following would you suggest as a remedy? Will you give lemon juice or will you give vinegar or baking soda? Which property did you think of which choosing the remedy? Surely you must have used your knowledge about the ability of acid and bases to nullify each other's effect. Then you will give the proper remedy. So to understand what is acid and base, let's start one by one. Acid Acid are sour in taste and changes the color of blue litmus paper into the red litmus paper. If blue litmus paper deeply in the acid, then color changes to the red. Similarly, bases are bitter in taste and changes the color of red litmus paper into the blue. Observe this table, friends, in which the first molecular formula is HCl. So the basic radical will be H plus and acidic radical is Cl minus. Friends, basic radicals means the radicals having positive charge and acidic radicals means the radical having a negative charge. So H plus and Cl minus. Definitely another example, in the case of HNO3, H plus is a basic radical and acidic radical NO3 minus. H2SO4 sulfuric acid in which H plus and SO4 minus. Same case NaOH and Na plus OH minus KOH K plus and OH minus K Ca plus plus and OH minus. In the case of NaCl sodium chloride Na plus and Cl minus. K2SO4 K plus and SO4 minus minus are the radicals, and the last example CaCl2 in which Ca plus plus calcium and chlorine minus. These are the, after the ionization, what happen? The the compounds ionizes. What happen? One basic radicals and another acidic radical will form. So now we have to write the types of compounds. So types of compound we can say either this is a acid or base or ions. So it's depend upon, the first point is that some compounds are seen have a H plus in the basic radical. See, in the first three compounds the basic radicals are the H plus, means if some compounds are seen having a H plus as a basic radical, then that type of compounds are called as acid. Similarly, in the case of NaOH, KOH and CaOH, what happen? In the acidic radicals, see friends, in the acidic radicals OH minus is there. So some compounds are seen to have OH minus as acidic radicals in their molecules, so are called base. And the third type, those ionic compounds which have a basic radical other than H plus. Here H plus is not present. In the NaCl, Na plus is there. In K2SO4, K plus is there. In CaCl2, K plus plus is there. Means the basic radicals is other than H plus. And acidic radicals are other than OH minus. Means in the first case Cl minus, then SO4 minus minus, and then Cl minus. Means other than OH minus are present. If the basic radicals are other than H plus and acidic radicals are other than OH minus, then that type of ionic radicals are called salts. So this is a simple concept of acid, bases and salt. Now see the Arrhenius theory of acids and bases. Swedish scientist Arrhenius put forth a theory of acids and bases in the year 1887. This theory gives the differentiate or the definition of acids and bases as follows. So according to the Arrhenius, acid means the acid is the substance which on dissolving water which gives H plus ion, and that ions is nothing but the cations. The cations means the ions having a positive charge. For example, HCl, H2SO4, HNO3. HCl means hydrochloric acid, H2SO4 means sulfuric acid, and HNO3 means nitric acid. So, if HCl, H2SO4 or HNO3, these acids, when dissolved in the water, what will happen? They will definitely give H plus ions. So, this type of compounds is called as acids. See this, if the HCl dissolve in water, dissociate, what happen? H plus is give. H2SO4, in the case of H2SO4, when dissociated in the water, definitely H plus will create. Then in the case of base, a base is a substance which on dissolving water gives rise to the OH minus. In the case of acid, after dissolving the water, what happen? H plus, acid is the which gives H plus ions, but base are the compound which gives OH minus ions, and that OH minus ions are nothing but the anions. So anions are the ions which having a negative charge, that are called as anions. The example of bases are NaOH, sodium hydroxide, calcium hydroxide, CaOH. See the example. For the dissociation in the water, NaOH split into the Na plus and OH minus, means here OH minus, and here also in the case of calcium hydroxide, OH minus is dissociated. So now classification of acid and bases. So classification of acid and bases: strong and weak acids, strong and weak bases, and alkali. So acid and bases are the classified into the strong and weak, these two types only, on the basis of how many ions are gives, or how many or on the dissociation capacity in the aqueous solution. See, in the case of strong acid, what is meant by strong acid? Strong acid means nothing but the on dissolved in water, strong acid dissociate almost completely. Means strong acid. Suppose for example HCl, HBr, HNO3, and H2SO4. These are the strong acid. Strong acid are completely dissociates in the water. Means completely dissolve in that water. So that is called as strong acid. In other word, strong acid gives more and more number of H plus ions. In the case of weak acids, exactly opposite. On dissolving water, weak acids does not dissociate completely. Means weak acids does not dissolve completely. Means in other word, weak acid does not give H plus ions more. In the strong acids create H plus ions more, but in the weak acid, H plus ions are weakly dissociated, gives less. The examples of weak acids are acidic acid and carbonic acids. Same in the case of strong base. Here in the strong acid, H plus ions gives more. Here in the case of base, OH ions gives more. Means on dissolving the water, the strong base dissociate almost completely, and resulting aqueous solution contains mainly OH minus ions. Means gives maximum OH minus ions. The examples of strong base are NaOH, KOH, COH taken twice, and Na2. Second, weak base. In the case of weak base, on dissolving the water, a weak base does not dissociate completely, and the resulting aqueous solution contains small portion of OH minus. Means in the same case, in this weak acid, definitely that acid does not dissociate completely. Here also, weak base does not complete dissociate in water, and resulting, what happen? It gives less number of OH minus ions. Examples are ammonium hydroxide is the example of a weak base. This is exactly difference between the strong acid, strong base, and weak acid and weak base. Now friends, what is alkali? Alkali is the base which are highly soluble in water. Example, NaOH, KOH are strong alkalis, and ammonium is a weak alkali. Okay friends, this is the first part of video. If you like my